All right, welcome to today's mini lecture. This is Drawing Lewis Structures Part 2. In Part 1, we talked about the duet rule and the octet rule, and there's primarily one element that holds to the duet rule, and that's going to be hydrogen, every now and then helium. The octet rule fits the rest of the elements on the periodic table. Duet rule means that you need 2 electrons in its outer energy level, whereas the octet rule is 8 electrons in its outer energy level. So what we're going to do is we're going to look at drawing the Lewis the Lewis structure for compounds that contain double bonds. So if you remember, a single bond is going to be 2 electrons that are shared. So you get one shared pair of electrons, so 2 electrons. A double bond, you got 2 electrons from this atom, 2 electrons from this atom, so you get 2 pairs of shared, or 4 electrons. And then, of course, a triple is 3 paired shares, or 6 electrons. So let's go through and look at how we do this. Bottom line is we still want to make sure that we follow our rules. So I have the screen that has the rules so you can see it as well. And it says, number 1, add up the total number of valence electrons. So I come over here, I have CO2. So I'm going to say valence electron is equal to. So I'm going to look over there and my carbon has 4 valence electrons. My oxygen has 6 valence electrons. Remember, I have 2 oxygens, so that's going to be a total of 12 valence electrons contributed by the oxygen, 4 more from the carbon, for a total of 16 valence electrons. Always make sure that you write out as your central element the one that is the least representative. So I have 1 carbon, so it goes in the center. I'm going to connect an oxygen and an oxygen. So we start off, just like we always do, connecting with a single bond. That's going to be 2 electrons. This represents 2 more. So I have used 4 electrons. So now I have a total of 12 electrons left. We always distribute the remaining electrons to your peripheral element first. So I look at that, I got oxygen. So oxygen has 2, so it needs 6 more. 1, 2, 3, 4, 5, 6. That means it is now at the octet. 1, 2, 3, 4, 5, 6. I have used all 12 of my electrons. I have no more remaining, so I am now finished. But big thing here is everything stable? So I look at it and I say, this oxygen here has 2, 4, 6, 8. It's good to go. This oxygen, 2, 4, 6, 8. It's good to go. But look at my carbon, 2, 4. That's not good to go. So what happens is we're going to have to share electrons from our one that is in the peripheral. So do you see how these 2 electrons are dedicated just to the oxygen? Well, if I erase those 2, I can now draw another line in the center, which means now those electrons are being shared between the oxygen and the carbon. So that gives me 2, 4, 6, 8. So my oxygen's still good. 2, 4, 6 right here. So now my choice is, am I going to try to share another pair here and make it a triple bond, or do I share a pair over here and make it 2 double bonds? Guys, general rule of thumb. If the element is in the halogen family, which is the very last one, fluorine, chlorine, bromine, iodine, single bonds always. If it's an oxygen, sulfur, selenium, tellurium, double bonds. And nitrogen, phosphorus, and arsenic are going to be your triple bonds. So you have those just kind of giving you a little bit saying this probably is going to work. Since I have oxygen here, yeah, I'm going to erase that and I will put right here as my double bond. So that's going to be a double bond. How does that look? Well, I like our little molecular model kits because they show us a stick that's this size for a single bond, a stick that's, this size for a triple bond, and then we know that the double bond would be somewhere in between these 2. So if I look at this, you see how I've got springs? Well, the spring is the same distance as the single bond, except now it's going to be bent over. So it's going to be, and if I look at this, you can tell it is a little shorter than the single bond, but it's longer than the triple bond. And that's exactly it. Single bonds are going to be the longest, least energy, double bonds next, and then triple bonds are going to contain the most energy, and they're going to be the shortest. So I look at this, and you see how I got the central carbon and then oxygen on each side. You see how it's in a line, right? All on the same plane. That's called a linear structure. All right, so let's go through and look at the next one. I have nitrogen up here. Now this time it's a little different. Nitrogen's bonded with nitrogen. So do I have a central element? It's the same element. How many do I have? It's not surrounded by, I only have two. If you only have two elements, guys, when I still start off, I need to count my valence electrons. I almost got ahead of myself. Valence electrons, so nitrogen has 5, so that's going to give me a total of 10 electrons. So I'm going to come back over here and put a nitrogen attached to a nitrogen. So that leaves me with 8 electrons. So now I'm going to put 1, 2, 3, 4, 5, 6, 7, 8. That's it. I look at this and I say, wow, that is way, way lopsided. We've got 2, 4, 6, 8 for this nitrogen, 2, 4 for this nitrogen. I can't just make up more electrons and start throwing them in there. I have to use what I have. So I'm going to erase that pair right there and make it shared. I'm going to erase that pair right there and make it shared. So now I have 3 lines. 1, 2, and 3. That's a triple bond. 2, 4, 6 electrons are shared. Then this one has 2 more for 8. This one has 2 more for 8. So guys, it's one-on-one. It's only 2 elements. It's like if you put 2 dots on a piece of paper, you can only connect them with a straight line. So then again, this is called a linear structure. All right, I'm going to go ahead and just go straight into the next one, the valence electrons. And this is sulfur and oxygen. So oxygen has 6, sulfur has 6. 6 times 4 is 24 valence electrons. So I put my sulfur surrounded by 3 oxygens. So I've used 2, 4, 6. So that means I have 18 electrons left. So I'm going to go around and put 6 electrons around that oxygen, 6 electrons around that oxygen, 6 electrons around that oxygen, for a total of 18 used electrons. So now I look back up here and I say 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. My oxygens are great. They all went around the peripheral. But my sulfur only has 2, 4, 6. So I can't make up electrons. I have to use what I've got. So when I look up here, I say, okay, that means I got to have a double bond somewhere. So does it matter where the double bond? Can it be here? Absolutely. Well, what if you said it's here? That's fine too. Well, what if you said it doesn't matter, guys? So I'm just going to take 2 electrons that are right here on the top of that one. I'm going to draw this in right here. So now I have 2, 4, 6, 8, and everyone is at the octet rule. Now, if you had drawn yours right here, it would look different. We call that a resonant structure. Resonant means that it's just changing, but it's still the same thing, SO3. Lastly, SO3, let me go through with a double bond, tell you what it looks like. You have no lone pairs of electrons, so everything has to be on the same plane. And you can tell wood ones, longer, and then the double bond here is shorter. But it's still going to be on the same plane. So it's got 3 around it. So we already said the prefix for 3 is trigonal. And this time it's not in a pyramid like we did earlier. It's on the same plane. So we call that a trigonal planar. All right. So let's keep going. I got one more I want to do. And we need to start by counting the valence electrons. So 3 and S, that's going to be 24, but this time it has a -2 charge. So that means I had to gain 2 more electrons. So I don't have just 24, I have 24, then it's 25 and 26. So this time, still looks the same. I'm I'm setting it all up. And then I have 2, 4, 6 used. I have 20 electrons left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I've used 18 electrons. That means that I have 2 electrons that I've not used yet. Those 2 electrons, I have to place them. I can't just say, they're extra. Now, got to come back in. Anything that you have left after octet, octet, octet for your peripherals have to go on your central element. So now I just put those 2 together. I have 2, 4, 6, 8, and everybody else is at the octet rule. I look at this. You see how I got a lone pair of electrons there? Right. That means that they're going to occupy the electrons or the northern hemisphere, and then it pushes everything back down. So instead of getting the structure like I just did with the SO3, which is trigonal planar, what ends up happening is it becomes trigonal, and this is pyramidal. Trigonal, pyramidal. This one has a set of a lone pair of electrons right up here. So it's occupying up here, pushing everything else back down. All right, so that covers all of the examples that we had in our notes. You'll see that part of our directions are, as you're watching the video, you need to go through and write down and figure out or complete the Lewis structures for each one. All right, I hope that was helpful, and I'll see you in the next mini lecture.